1.3, we're going to be estimating limit values from tables. So basically in this lesson, what we're going to be doing is really just focusing on tables, but this takes that same exact idea of limits, that whatever x is approaching, what is the output approaching? So here we have our x values on the top there, our y values on the bottom. That's typical, unless I think down here you can see there's a vertical table. See, these are the x values, those are the y values. So we got to pay attention, what's the left hand, what's the right hand, and then just kind of picture the graph. What are the values getting close to? Now remember, what's important for this next one, if you read our objective, is to determine if a table is appropriate to approximate the limit based upon the given input values. So we really want to focus on this table and think, are these values getting infinitesimally close to the number that we're looking for? We don't want it to be far away from the number. For example, let's just say we want the limit as x approaches 3. We wouldn't want our values to be like 0, and then 1, and then 2. That's not approaching 3 infinitesimally. We want it to be getting super, super close, like 2.9, 2.99, 2.999. We want that to just keep going and seeing what it's getting closer and closer to. Also, remember, with limits, we want to make sure, unless it specifies a left or right hand limit, we need to check both sides, because if it fails, if it doesn't have the same limit from both sides, then the limit does not exist. So we need to see the limit from both sides, unless it specifies. I think if we get down here to 1.3.3, you'll see it's one-sided limits, where it will specify the little plus sign or minus sign that they want the limit from the left or the limit from the right. So let's look at these examples. So we want to see, is this table accurate, or each table is accurate, but which one's the best for approximating the limit? So we want the limit as x approaches -7. So what we should do is start by finding where would -7 be located. So here's -8, and if you see, this is going -7.5, then -8. So the next thing would be like -8.5 or -9 or something like that, a greater negative number. So what about over here? -7.1, -7.05, -7.001. So -7 would probably be located right here. So the problem here is not that it's the number is getting really close to -7, as it should. But what about the limit from the right? We don't have that limit from the right. So this one's going to be out. What about B? Let's look at this one, -7.1, -7.05, -7.001. So that's getting really, really close to -7. So -7 would fall right there, because look at this. This is the limit from the right, -6.9, -6.95, -6.999. So that would be approaching -7 from the right. So there you have it. The left and the right, it's getting super, super close to -7. And so that one checks off. That's a good one. Let's just check C, just see what's wrong with this one. -6.99, -6.95, -6.9. What you can see here is this starting with -6, and it's getting closer and closer to -7 from the right, but we're missing that left-hand limit. So that one does not work. So I'm going to go ahead and just X that one out. So B would be our answer there. If you look at this one, it's going to be the same kind of question. So I'd recommend that you guys work on that one. Let's look at this one. So is the table appropriate for approximating the limit as x approaches 9? So look at this. This is jumping +2, +2, +2. It's not giving me those decimals. I want to be seeing something more like 8.999, 8.9, 8.5. We want to be seeing those numbers really close to 9 for the limit. And this is just jumping in steps, and so we don't really know, is this really getting close to that value or not. So this table's not appropriate because it's doing those jumps. And so let's see what the explanation is. The table isn't appropriate. The x values only approach 9 from one direction. No, it approaches 9 from the right side as well. We just didn't look at it. But the table isn't appropriate because the increments in x values are constant. We want them to be in decimals. We want them to be getting closer and closer and closer to our number. And so this one, why isn't this one appropriate? Let's just go through this one as well. So if we look at this one, it's getting closer and closer to -2. Look at that, -2.1, -2.01, and then -2. The problem is, look, this limit wants the limit as x approaches +2. So we don't want to do -2. We want to be seeing it approaching +2 from the left, like 1.9, 1.99, and so on. We want to see it getting closer to +2 from the left. So that one's not going to work. So let's see the justification here, the table doesn't contain x values from both sides of x equals 2. Now, originally when I read this, I thought that, but think about it. The negative 2, that is actually from the left side of 2. So this table actually does contain x values from both sides. It's just the left side's not close enough to 2. The x values are approaching from the left shouldn't be negative. Yeah, they shouldn't be negative, they should be positive, getting really, really close to that value of 2. And there you have it. That's just more of an introduction to limits as tables. I think the next assignments are a little bit easier, a little more straightforward. But basically here is the table appropriate? So what we're really looking for is are the x values getting really, really close to the x value that we're looking at? And is it going from both sides?